Hey guys, today we're going to learn about scientific notation and standard form. Standard form is just a normal number, the way you and I write out numbers in our day-to-day life. Scientific notation is a way to express really large numbers and really small numbers. We're going to practice changing scientific notation to standard form. If scientific notation has a positive exponent, it's a really large number. Here we have 10 to the 4th power. Since the 4 is positive, we know that this 8.4 is going to have to get changed into a large number. And we're going to change it to just a normal number in the standard form. The exponent tells you how many times to move the decimal. And since it's a positive exponent, it's going to be moved to the right. So we're going to start with 8.4. And we want to move the decimal 4 places to the right. 1, 2, 3, 4. Now you're going to fill in these empty spaces with zeros. So 8.4 times 10 to the 4th power is the same as 84,000. Now let's try one with a negative exponent. Again, the exponent means to move the decimal. Since it's a negative, we want to move the decimal place over to the left. So we're going to use the number 7.32. And we want to move this decimal place over to the left 7 times. 1, 2, 3, 4, 5, 6, 7. And in these empty spaces, we're going to fill in our zeros. So our answer is going to be 0.000000. That's 6 zeros. 1, 2, 3, 4, 5, 6, 7, 3, 2. So if it's a positive exponent, move the decimal to the right. If it's a negative exponent, move the decimal to the left. Let's try going the other way. So we're going to go from a standard form number to scientific notation. Our goal is to get one number in front of the decimal that's not 0, and then a decimal, and then any other number other than 0 would go after the decimal. So our goal here is to make this number 8.3 times 10 to the, now we need to figure out what exponent we're going to need here. It's a large number, which means it's a positive exponent. We need to figure out how many times the decimal would need to move to make it between the 8 and the 3. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our decimal moves over 10 times, so it's going to be a positive 10 exponent. So this number is the same as 8.3 times 10 to the 10th power. Okay, let's try this last one. Again, I'm noticing a 785 back here, and so there needs to be one number that's not 0 that's out in front of a decimal. So the first number I see is a 7. and then the other two numbers will follow. It's always going to be times 10. Now the power is how many times we move the decimal over. 1, 2, 3, 4, 5, 6, 7. So it moves over 7 times. This is a really small number. It's a number between 0 and 1. And so our exponent is going to be negative. The negative exponent does not mean that it's a negative number. It means that it's a really small number. The exponent does not tell us how many zeros there are, like how many zeros are here or after the 83 in this number. It tells us how many times we move the decimal. Now, scientific notation, again, is a way to express really large and really small numbers. When we have really large and small numbers, sometimes we don't want to write them all the way out. And so a lot of professions, they use scientific notation to show these numbers. First, we practice changing scientific notation to a standard form number. Remember, the exponent tells you how many times to move the decimal, and then the positive means a really large number. The negative means a really small number. And then we practice changing a number from standard form to scientific notation. Remember, there always has to be a number out in front of the decimal that's not 0, and then a decimal point, and then the other numbers that are not 0 go after the decimal point. Remember, the exponent does not tell you how many zeros you see in a number. It tells you how many times to move the decimal. Thanks for watching.